Hello, is it audible?
Yes, sir.
Okay.
Yes, sir.
So we have started the AC circuit with a pure inductance, and we have discussed already about the voltage equation, current equation, and power equation, and the phasor diagram, circuit diagram, and waveforms of the voltage and current, and instantaneous power derivation also you have taken now. Yes, up to here you have taken, I think. So the average power in pure inductive circuit is 0, or in other words, the power consumed by a pure inductance is 0. So from this equation you see here, this is the voltage waveform, and this red color, this one, chocolate color, you consider that one, it is a current waveform, but the voltage waveform starts from 0, but the current waveform, it is starting 5 by 2, starting at 5 by 2. So voltage is starting at 0 and current is starting after some angle of 90 degree. So current lags the voltage. Current lags the voltage by 90 degree. We can say that one here now. So from the power equations, so 1/2 cycle of the current and voltage, we can consider Vm Im here now. Vm is this one, Im is this one, divided by 2 is there. At the value of 45 degree into 2, it's nothing but sine 90. At that value is minus value is there, so it is negative value. So negative value means it is when the power is negative, then the power flow from inductor to source, it will go here. Now when it will positive, it will flow from the source to inductor. Source to inductor means positive, and inductor to source means negative here now. So in one cycle of 20 to 25 within a 360 degree, it will complete 2 cycle of the power. Here you consider here now minus power, this is maximum power, here plus maximum power here now. So both are in positive, negative power supplies are there, power consumed by the inductor. So at the average value of this one, the positive cycle will complete cancels the negative cycle. So the average power for the AC circuit with a pure inductance is 0. We are going to consider average power for that one is 0 here now. Have you taken this diagram, all of you?
Yes, sir.
Yes, sir.
Next line you write down. Next line, all of you write down. The voltage, comma current, the voltage, comma current, and the voltage, comma current, and power waveforms of a purely inductive AC circuit, power waveforms of a purely inductive AC circuit, purely inductive AC circuit is shown in the above figure. Shown in the above figure. Is shown in the above figure. Full point. Full point. Next line. From the above figure, as seen from the power waveform, from the above figure, comma, as seen from the power waveform, the instantaneous power is alternately positive and negative. positive and negative. Full point. Full point. When the power is positive, next line read. Next line. When the power is positive, when the power is positive, the power is positive, comma, the power flows from the power flows from the source, from the source to the inductor. The power flows from the source to the inductor. And when the power is negative, comma, when the power is negative, comma, the power flows from the inductor to the source. Inductor to the source. Inductor to the source. Full point. Full point. Next line. Next line. The positive power is equal to the positive power is equal to the positive power is equal to the negative power. The positive power is equal to the negative power, and hence the average power in the circuit is, the average power in the circuit is, equal to the, zero, Full point. The power just flows between the power just flows between the source and the inductor. Comma, but the inductor does not consume any power. The inductor does not consume any power. Full point. Full point. Okay, over.
Yes, sir.
Yes, sir.
Next heading, you take down AC circuit with a pure capacitance. AC circuit with a pure capacitance. Have taken the heading?
Yes.
Yes, sir.
Okay, listen now. Stop writing. So we have discussed about the AC circuit with a pure resistance over inductance over. So pure capacitance, in the place of inductor and resistance, we have added here a one capacitor here. One capacitor. Actually, they have to keep for the charging of capacitor, discharging and all the things, but it is not there for your syllabus. No need to worry about that one. You know about that one, electrical charge, Q equal to VC and all the things, I think. Yes, the formulas and all the things. We'll discuss about later here. So here, the across the capacitor, the AC voltage source is supplied here now. It is connected across the capacitor here. Because of this supply, the current flowing through the circuit is I we have considered, and the voltage across the capacitor is nothing but VC is equal to V. Is equal to V. We are going to call that one here now. VC is same as the supply voltage. So from this one we are providing the AC supply voltage here now. So we know that one voltage applied here now, instantaneous voltage is V equal to Vm sin omega t. We can write this one. Yes. So
Yes.
V equal to Vm sin omega t, that is equation number 1. So for the voltage equation, there is no problem about that one here now. Next, we have to identify current equation and as well as the total power equation of the circuit we have to identify here now. The voltage equation is V equal to Vm sin omega t. Next, we will go further to identify the current equation. We know the Q equal to CV. All of you know that one.
Yes, sir.
This formula,
Yes.
the basic charge equal to capacitance of a capacitor and voltage here now. Product of voltage and capacitance we are going to call that one. Q equal to CV. We know the basic formula of the charge here now. Yes, the Q is the charge stored in the capacitor. We are going to call that one here now. So this Q equal to CV, we know the formula. So Q as it is you keep here, C also you keep as it is. This V formula we have identified from the equation number 1, this one.
Yes.
So from equation 1, you substitute the V value here now. V equal to Vm sin omega t. In this place of V, we'll write Vm sin omega t here now. So now Q equal to C Vm sin omega t ho gaya. Okay. So for the capacitance circuit, the electric current is the rate of change of charge here now. Rate of change of charge we are going to consider here now. So I equal to dq by dt. We can write rate of change of charge. Yes?
Yes, sir.
So I equal to dq by dt. We know the formula. The current flowing through the pure in the capacitive circuit is the rate of change of charge we can consider here now. Okay. So I equal to dq by dt, we consider that one. So this q value we can substitute C Vm sin omega t. I will substitute here. So I will write as it is equal to, and this one C q in the q place I will write C omega m sin omega t. I will substitute here. So differentiation of sin omega t.
Cos omega t.
Cos omega t into omega.
Omega, because with respect to t we are doing here, omega t is there. So omega cos omega t is the differentiation of sin omega t. So C Vm I will write as it is, omega cos omega t, the differentiation of this term we have written here now. So next I equal to C omega m, omega C Vm I will write here now. This cos omega t we can write sin omega t plus 5 by 2.
Yes.
Sin omega t
Yes, sir.
plus 5 by 2 you can write down here now. So this omega c into Vm is nothing but I will consider as Im here now. I will consider as Im. Actually, Im equal to Vm by Xc we are going to consider. Xc is the capacitive reactance. जैसे हमने इंडक्टिव रिएक्टेंस कैलकुलेशन किया ना इधर, XL equal to omega L लिखा है. Yes?
Yes.
Inductive reactance. But the capacitive reactance is different. That is called XC. It is nothing but not XL. This one. XC equal to 1 by omega C, or 1 by omega C equal to XC we can write down. 1 by omega C equal to XC, or omega C equal to 1 by XC we can write down here now. समझ में XC equal to 1 by omega C. How it is there here now? omega c into Vm is there. So omega c equal to 1 by xc we can write down here.
Yes, sir.
1
Yes,
by
sir.
xc. So Vm by 1 by xc is nothing but Im we can write down. Reactance is same like a resistance only, na? According to Ohm's law,
Yes, sir.
I equal to V by R. So V by X is nothing but
I.
I only. So maximum voltage is there, maximum current we can consider here now. So this equation I equal to Im sin omega t plus phi by 2 is the current equation. This is equation number 2. We are going to call that equation number 2 here now. This one is equation number 2. Is it clear?
Yes, sir.
Next. Will come here now. Just one. Just now I told that one. Xc equal to 1 by omega c. Omega is nothing but 2 phi fc. Omega equal to 2 phi f, and c I will write as it is here now. So xc equal to 1 by omega c. Otherwise you can write omega c equal to 1 by xc also. You can write that one. While dictating, I will write the formula that one. So Im equal to Vm by xc equal to V omega c into Vm also we can write down that is. Is it okay? Now
Yes.
this one. Okay. So we have derived the voltage equation and current equation. Our next aim is to power equation we have to derive. That is, the power equation is, we know the instantaneous current equation, we know the instantaneous power equation. Then P equal to the instantaneous power equal to product of instantaneous voltage and instantaneous current. So P equal to VI I will use here now. This V we know from the equation 1, we can write Vm sin omega t. And the I value also we have derived, that is equation number 2, that is Im sin omega t plus phi by 2. That is the formula here now. So both are equation 1 and equation 2 I will substitute in the instantaneous power equation. Vm I will write here Vm, and sin omega t also I will write as it is here now. Sin omega t plus phi by 2 is nothing but cos omega t. Cos omega t is there. So we can write down not cos omega t. Sin omega t plus phi
Yes,
by 2.
sir.
Okay, cos omega t. So sin omega t into cos omega t is nothing but 1 by 2 sin 2 omega t we can write down.
Yes,
Yes,
sir.
sir.
We know the formula, sin 2 omega t equal to 2 into sin omega t cos omega t. But when we will sin omega 2t, sin 2 omega t divided by 2 equal to sin omega t cos omega t we can write. So that formula we have used here. Now Vm Im as it is, sin 2 omega t divided by 2 we are using here. Now that 2 only I have written here. So this is the instantaneous power of the AC circuit for pure capacitive load. For the pure capacitive load. What do you think about the instantaneous, sorry, average power here now again?
0.
0 high. The instantaneous power is fluctuating part is there here.
Yes, sir.
Fluctuating part. Sin 0 into anything, it is 0 only. Okay. So sin 0 equal to 0. So again here 2 omega t is there. Omega t equal to 45 degree. 45 into 2,
90.
90.
by
Sin
2.
90 equal to 1. So here
1.
negative sign is not there, positive sign is there. So Vm Im by 2, we are going to get that one. So at 45 degree, we are going to get the maximum peak value, that is positive peak value of the power we are going to get. At 45 degree, positive value of the positive peak value or maximum value of the power we will get here now. Okay. At 90 degree, 90 into 2,
180.
sin 180 equal to
0.
0. So again for the 90 degree it will come back to the 0 here. Next 135. 135 into 2,
270.
270. Sin 270 equal to
-1.
-1.
-1. So at 135 degree it will come negative peak value it is going to get here now. Negative peak value it is going to get here now. So sin 180 degree, sorry, 180 into 2,
360.
360.
sin 360 equal to
0.
0.
0. So within one half cycle of the voltage and current, 0 to 5 only, it will complete positive half cycle and negative half cycle, complete one cycle here now. So positive value and negative value gets cancelled here now. So for that reason, the instantaneous power has only fluctuating part. The average power of this circuit will become 0. We can say 0 here. Yes. So that
Yes,
one
sir.
only we have written here. The average power from the instantaneous power, we can find the average power over one cycle, 1 by 2 5, 0 to 2 5 Em Im by 2 here. So sine this value fluctuating part, whatever we will give here now, after substituting, after doing the integration and substituting this value 0 and 2 5, we will get the value of 0 here. Now 1 minus 1, we will get that one. After integration, we'll get 1 minus 1 is nothing but 0 only.
0.
Na? 0 into
0.
anything is nothing but 0 only.
0.
0.
0 multiplication to anything, it is 0 only. So average power of this one will become 0.
0.
Average power of the circuit will become 0. So next one. Here we have drawn the power equation here now. See, compare with inductor circuit and this capacitor circuit. What is the difference between these two circuits? Just tell me. Is there any
करंट एंड
difference?
वोल्टेज
Sir.
0 से स्टार्ट हो रहा है.
कौन सा?
करंट एंड वोल्टेज
Current and voltage.
स्टार्ट्स
हाँ
फ्रॉम
हाँ,
0.
just a minute. मैंने phasor diagram explain नहीं किया ना?
यस.
Okay, okay. Listen here. This is the phasor diagram and this is the voltage waveform here now. See, comparing with these two equations, V equal to Vm sin omega t. So voltage will start, voltage waveforms are starting from 0 and first half cycle will complete at 5 and next half cycle 5 to 2 5 it is completing here. Yes, according to the voltage equation here now. Now consider here I equal to Im sin omega t plus 5 by 2 is there. Plus 5 by 2. This is sin omega t. Where is the plus 5 by 2 here? Plus 5 by 2 means here voltage is starting from 0, but the current is starting before the voltage. Before the voltage 90 degree it is starting here now. So that one we are going to call as leading, current is leading the voltage by 90 degree. इधर से चालू हो रहा है. This is called minus 5 by 2. This is minus 5 by 2. Minus 5 by 2. So negative side it is starting here now. So 0 omega t minus and minus. Minus of minus is it will become plus only na.
यस.
Sin omega t
Yes,
plus
sir.
5 by 2 we are using here. No. So 0 से पहले ही current चालू हो रहा है. Current is starting from before the 0. Before the 0 90 degree पहले ही चालू हो रहा है. For that reason sin omega t plus 5 by 2 we are writing here. No. But the voltage equation is sin omega t only is there. So for that reason we can clearly say that current is leading the voltage by an angle of 90 degree. Current leads the voltage by 90 degree, we can say here now. We can say here now. So from the waveform and from the equation I am taking the voltage and as a reference here now. So our rotation is anti-clockwise direction. The generation rotation is anti-clockwise direction है. So current voltage से पहले current चालू हो गए. इसको डाउन साइड लिखना है क्या अपर साइड लिखने का?
Upper.
अपर. व्हाई? सो वोल्टेज से पहले करंट चालू हो गया, वो भी 90 डिग्री पहले ही है. 90 डिग्री फर्स्ट. इट शुड हैव टू मेंटेन ओवर 360 डिग्री. इट शुड हैव टू मेंटेन 90 degree difference here now. So at 90 degree the current we have drawn here, that is I here now. That is called I. We are going to call that one here now. So this is the voltage and current waveforms. This is the phasor diagram. We are going to call that one here now. So from this one we'll go further. We'll go further where it is waveform. Current and voltage waveforms we'll discuss here now. So here, listen carefully. The current is starting from minus side here now. Current is starting from minus side. So according to the instantaneous power equation, according to this instantaneous power equation, P equal to Vm Im by 2 sin omega t. So at sin 0, it should have to answer should be 0. Sin 45 degree, at 45 degree, this is the 45 degree, yes? See here, this one is 5 by 2. Half of that one is 5 by 2 is there. 5 by 2 का आधा किधर आ जाए? Here we will get that one. Yes.
Yes.
Yes, sir.
Sin 45 degree into 2 is nothing but sin 20. Sin 20 equal to 1. So the whole answer will become 90. Sorry, maximum power we are going to get at this point at 45 degree. Just a minute. बोलिए सर. So here positive half cycle and negative half cycle will get cancelled here now. So positive power and negative power. So the average power will become 0. We can say that one. So this is the power waveforms. So 45 degree, 135 degree like that. So 90 degree difference, it is going to get the maximum value. It is going to get that one here. So is it clear? If you have any doubts, you can ask me now. You can ask the doubts. Any doubts?
No, sir.
No doubts. Okay, take down then. You take the diagram. This diagram you take down. First only diagram ले लो, उसके बाद मैं डिक्टेशन कर देता हूँ. Only you take the diagram. Is it over?
Yes, sir.
So you write next line. You write down. Consider an AC circuit. Consider an AC circuit. Consider an AC circuit with a pure capacitance C. With a pure capacitance C. Pure capacitance C. As shown in the above figure. As shown in the above figure. As shown in the above figure. Full point. Full point. Just a minute. Oh, sir. क्या कर रहे हैं? As shown in the above figure. Next line. The alternating voltage V, the alternating voltage V of a given alternating voltage V is given by, the alternating voltage V is given by, you write this complete equations and up to here you write the equation, write up also. No need to dictate this part. लिखते हैं ना? Complete. Hello.
Yes, sir.
Yes, sir.
There is one company came for the interview. I have some work. You people should write down that this one up to here you write down, and after completing of this one you just let me know. I will shift into next slide. Okay.
Yes.
Over.
Yes, sir.
Yes, sir.
Up to here it is over. Okay. The next slide. Don't write this all the things here now. Don't write this all the things. So we can find the current through the capacitor as follows. लिखा है ना?
Yes, sir.
Yes, sir.
इसके बाद क्या करो? Directly we know that. You write down. We know that. Don't take this diagram. Don't take this, write this expression. We know that. We know that. ये equations लिखो. Complete equations लिखो इधर. हरबज आए क्या इंटरव्यू के लिए?
नहीं सर.
कौन कौन आने वाला है इस क्लास का? कोई मालूम है क्या कुछ?
नहीं सर, मैं बीमार हुई थी.
ऐसा है क्या? हाँ, तुम्हारा क्लास से कोई नहीं आ रहा है क्या?
क्या पता सर.
कौन कौन?
वेदांत आएगा सर.
हाँ,
वेदांत आने वाला बोला था.
वेदांत जादव. ठीक है. Write this one. We know that Q equal to CV. Q equal to CV. C equal to V. Q equal to C Vm sin omega t. Q equal to C Vm sin omega t. After this one, I equal to dq by d. We know that I equal to dq by dt. I equal to dq by dt. I equal to dq by dt. एक सेंटेंस ऐड करो ना. Substituting C equal to Q equal to C Vm sin omega t in the above equation. We get, ये लिखो, थोड़ा स्टेप्स इंक्रीज करो. I equal to C Vm. इसके पहले लिखो dq by dt इक्वल टू, इसके इक्वल टू सामने लिखो d by dt C Vm sin omega t. Q का प्लेस में C Vm sin omega t लिखो. Q का प्लेस में C Vm sin omega t लिखने के बाद नेक्स्ट स्टेप लिखने का. After here you write down over. हो गया क्या इधर तक? सिर्फ only equations.
Yes, sir.
Only this part you have to take down. Have you taken this one?
Yes, sir.
Okay. Don't take the waveform and phasor diagram now. Next line you write down. See here. The capacitive reactance XC is given by, the capacitive reactance XC is given by, the capacitive reactance XC is given by, is given as, given by nahi, as given as XC equal to 1 by omega C, XC equal to 1 by omega C equal to XC equal to 1 by omega C, XC equal to 1 by omega C equal to 1 by 2 phi FC, 1 by 2 phi FC. Next line you write down. Therefore, I am equal to Vm by XC. Therefore, I am equal to Vm by XC. Vm by XC. See, these all formulas will come for 1 marks questions. You have to remember problems है इसके ऊपर, सब equation के ऊपर problems है. Remember the equations. Next line write down. It is equivalent to, capacitive reactance is equivalent to resistance in a resistive circuit, and the unit is ohms, full pad. Next line you write down. From the equation 1 and 2, from the equation 1 and equation 2, we observe that just a minute. we observe that in a pure capacitive circuit, in a pure capacitive circuit, the current leads the voltage by 90 degree. The current leads the voltage by 90 degree. लिख रहे क्या नहीं लिख रहे?
Yes, sir.
Yes, sir.
The current leads the voltage by 90 degree. Full point. Full point. Hence, the phasor diagram. Hence, the phasor diagram and waveforms of. Hence, the phasor diagram and waveforms of. Hence, the phasor diagram and waveforms of the voltage and current. The voltage and current are shown in below figure. Are shown in below figure. Are shown in below figure. Full point. You take these two phasor diagram. Sorry, this figure 2 phasor diagram, figure 3 waveforms. ये दोनों diagram लिखो. Write both the diagrams. Roll number 6. $13. 27. 29. $50, $53, $55, $56, $59, $60, $61, $62, $63, $63 है, $65, $67, $68. Okay. Over this phasor
Yes, sir.
diagram, figure 2 phasor diagram you have to write. Figure 3 we have to write as a waveforms here now. Voltage and current waveforms you have to write down. You have to take this one. Voltage and current waveforms. Over.
Yes,
Yes,
sir.
sir.
Okay, next line you write down. Taking heading you take down power equation बोल के लिखो. उसके नीचे instantaneous power बोल के small heading लेने का. And complete this all the things as it is. The instantaneous power in the above circuit can be derived as follows. P equal to VI, ये substitute करो, इसके P equal to VM IM by 2 sin 2 omega t. So this sin 2 omega t multiplication to anything is nothing but this is a fluctuating part. Fluctuating part is nothing but omega t is vary from 0 to 360 degree. So it can, the angle will be according to based on omega t, it is depends on that one. So based on that one, so it is the value of the P will be changes here now. For that reason, from the above equation, this equation we can say that one, the instantaneous power is fluctuating in nature. So it's varying in nature, not constant value. There is no constant value here now. Up to here you take down. Up to here you take down. Over.
Yes, sir.
Over. Others.
Yes.
2-3% ही रिप्लाई कर रहे हैं, बाकी नहीं ले रहे क्या शायद?
Yes, sir.
So instantaneous power is fluctuating in nature. अभी उसके ऊपर small heading ले लो, average power बोल के, average power बोल के heading ले लो. From the instantaneous power, average power बोल के heading लेने का, उसका नीचे लिखो from the instantaneous power, we can find, from the instantaneous power we can find the average power over one cycle. The average power over one cycle is as follow. Over one cycle is as follow. Write down P equal to, or PAB also you can write down average power also. P equal to 1/2 integration 0 to 25 Vm Im divided by 2 sin 2 omega t d omega t, sin 2 omega t d omega t. नेक्स्ट लाइन और एक लाइन लिखो इसमें, P इक्वल टू 1/25 इसको ऐसा इंटू 0 लिख देने का, इसको 1/25 इंटू 0, नेक्स्ट इक्वल टू P इक्वल टू 0. So this complete term will become 0. We have to show that one. This 0 into 0 is 25. Anything is nothing but 0 here now. So average power is the 0 here now. Over. Equation is over.
Yes, sir.
Yes, sir.
The average power in a pure capacitive circuit is 0. The average power in a pure capacitive circuit is 0. The average power in a capacitive circuit is 0. Or in other words, the power consumed by a pure capacitance is 0. The power consumed by a pure capacitance, is 0. Power consumed by a pure capacitance is 0. Full point. Next line. The voltage, current, and power waveforms. The voltage, current, and power waveforms of a purely capacitive circuit. Is as shown in below figure. Full point. So this diagram and all the parts will continue in the next class. This is the diagram you have to take down, but while writing this one, you have to consider this one here now. So this is the positive half cycle of the power here now. So you can make the design also for this one. So here our main aim is to show the only power waveforms here now. Already voltage waveforms and current waveforms we have discussed in the previous part. While deriving the current equation and voltage equation, we have discussed the voltage waveforms and current waveforms. But here we have to show the positive value of the power, negative value of the power, both are equal. So positive negative will get cancelled here now. For that reason, the average power is always 0 in the pure capacitive circuit. You can say that one here. You can say that one here now. So the power consumed by a capacitor is 0 for that reason. The average power is 0 means it is not consuming any power. If it is consuming for the positive half cycle, it is consuming something, negative half cycle is consuming. But the average, comparing the average value of that one will become 0. We can say that one here. So we'll stop here only and we'll continue in the next class.